Welcome to my YouTube channel. So this is our first lesson on linear algebra, and I decided to start from number systems. Okay, so I want us to go through all the number system kind of the numbers that you can think of. Okay, so if you are new to my channel, kindly subscribe to my channel, like my video, share it to others as well. If you're a returning subscriber, thank you very much for subscribing. All right, okay, let's get into the video now. Number system. So when you talk about number system, it contains all the possible numbers that has been discovered already. Okay, so first of all, I will start with natural. We mean by natural numbers, whole numbers, integers, rational and irrational, and then real numbers, and the last one is the complex numbers. With these complex numbers, we'll talk about it detailed in our subsequent lessons. Okay, but for the first five, we'll go through them right now, and I'll talk about the complex numbers. Very few, like I'll say very few words about them, and I'll do a new video talking about only complex numbers because it's a whole topic on its own. Okay, right, so let's start now with natural numbers. Natural numbers are numbers that start from 1, 2, 3. So basically they are the counting numbers. Okay, so you can say counting numbers are also natural numbers. In some books, that's what they write. Okay, so you can talk about any number from 1 to positive infinity. Okay, so like when you're talking about counting, they are only positive values that we count. Okay, so that's it. Now we go to the next number. Like I said, these are just a quick review about these. When we talk about whole number, the whole numbers are numbers that contains all the natural numbers and also contain the value 0. Okay, so 0 is actually a number. So when you include 0 to the natural numbers, then you have a whole number. Okay, so like I have here, very simple like that. So from 0, 1, 2, 3 going, then you have whole numbers. Okay, oh, this is cool. Now let's talk about the set of integers. The set of integers basically will contain the natural numbers, the whole numbers, as well as negative numbers. Okay, so if you have from negative infinity to infinity, all these numbers between being single whole numbers, then this is what we call integers. The moment I mentioned single whole number, I mean fractions are not part of this interval. Okay, you're talking about negative something, maybe negative, like I have here, negative infinity all the way to negative 2, negative 1, 0, 1, 2, going to positive infinity. Okay, so I hope this is cool. Now let's go to rational and irrational numbers. So these are the most how do I call it, confusing parts of number system. All right, so when I've used a table to differentiate these two. When we talk about rational number, a rational number can be represented in the form a over b, but irrational number cannot be expressed as the form a over b like I have here. It cannot be expressed as that. Now let me pick an example and show you why I'm saying this. So an example of a rational number is any fraction you can take of, let's say 2. Okay, 2 is a rational number, and this is the same as 2 over 1. And if I try to multiply or I can try to find a whole number that when I divide, I'll have something like two whole numbers. So I can write this as 4 over 2, and this is the same as 2, right? And this is the same as 8 over 4, 16 over 8. So you can think of plenty values. So 2 is a rational number because it can be represented in the form a over b. It can be represented in this form, that, and that. Okay, now let's pick an irrational number. An example of irrational number is what we call pi, or maybe root of 2, the square root of all the imperfect squares. So when I say when you have a perfect square number, it means that when you find the square root of that number, you get exact value. So 4 is a perfect square. It means its square root will give you 2. But irrational numbers are the square roots. Okay, the square root of imperfect squares. I mean square root of 3, square root of 2, square root of, let's say, 5, square root of 7. Those imperfect squares that you can think of. Okay, so square root of 2, yes, one will say that this can be written as square root of 2 over 1, but square root of 2 over 1 is the obvious, is the same as this. Okay, you've not changed anything. So now the question is, what again should I divide? What two numbers should I divide? Let's say a and b. That will give me square root of 2. Okay, so basically it becomes something else. It really becomes something else. You'd have to probably maybe, I don't know, but do something like 2 root 2 over 2. But these two numbers, this is already, square root of 2 here is already irrational, and it's involved this. But in the table, this a over b, a and b are just whole numbers. I wanted to include that, but I couldn't. Well, you can say, yeah, they are just whole numbers, or maybe integers. Let me put it that way. Integers will be very, very fine, because -7 is actually a rational number, but this is an integer, and this can be represented as -14 over 2, and this is correct, right? So yes, let's come to another difference between rational and irrational numbers. For rational numbers, the decimal expansion of rational numbers is terminating or non-terminating recurring. So I'll explain that point. But the decimal expansion of the irrational, represented by p, okay, so these are the representations, is non-terminating or non-recurring. Okay, so what you can do here is, right now, we can pick an example like square root of 2, pick your calculator and punch it. Okay, it will never end. You get different values. Okay, so if you want, we can all try it on our calculator. I have my calculator here, so you can point square root of 2, which is 1.41. If you extend your calculator, you can even use some programming languages like MATLAB or whatever, and increase the decimal values. You realize that it will be going and going and going. You get 1.41, 42, 1, 3, 5, 6, 2, going like that. Plenty, but different values. So this is non-recurring, non-terminating. It's never terminating. It's not also recurring. Now, when you have a rational number like 1 over 3, okay, this decimal is 0.33333, going like that. Okay, so it's non-terminating. Yes, this is, you have it's a terminating or non-terminating recurring. Okay, so what we mean is that it terminates. Either you have something like 1 over 2, and this decimal will give you 0.5. It will just terminate like this. But the decimal expansion of 1 over 3, this one, it's not the same, because it's, although it's a rational number, but it's non-terminating recurring. So it's not terminating, but it's also recurring with only one value. So you can have another example like 0.7, maybe something like this, 0.75757575 going. You can change this to your fractions by using a technique that most of us might have met it before. But if you want to change this to fractions, what you have to do is simply you let some y be equal to, let's say, 0.75757575 going like that. Then, since these two numbers are repeating, you multiply them by 1 with 2 zeros. Okay, so two numbers are recurring, so you use 1. If it was one number like 0.33, you just use 1, then you add 1 0 to it, you multiply to both sides. So this first one will be your first equation. Then you do for another one, when you multiply this both sides of the equation by 100, you get 100y equals 75.757575 going like that. Okay, then you subtract these two fractions, or sorry, these two equations. I mean, you subtract this equation, the first one here, from this one. When you do that, you get 99y should be equal to, when you subtract these two, you get 75. Okay, so you can see that y is now equal to your 75 over 99, which is the fraction we are looking for. Okay, 75 divided by 99, and this is the same as 25 over 33. Okay, the same as 25 over 33. But if you send this to decimal fraction, yes, you have 0.7575. So you can use this technique to look for how to convert recurring decimals to fractions. Okay, so that's the second point for you. And I go to the last one, which says some examples. So example of rational numbers, I've given you plenty. 4 over 5, 0.757575, like this. And for irrational, we have pi, root 2, root of 3. We have the the E value on your calculator, you can use shift plus the E pattern. I don't know if that is it, but shift plus, I think, yes, the part that the pi is, you have the pi, you get that value of E. Okay, so shift plus sorry, that is alpha plus that, sorry, and that is 2.718 something like, it will repeat like that. Okay, so now you go to real numbers. So when you combine the natural numbers, the whole numbers, the integers, the rational and irrational numbers together, we combine all of these numbers together, you have the real numbers. So the real numbers contain the natural numbers, whole numbers, set of integers, rational and irrational numbers. So these combine to form what we call a real number system. Okay, so mostly you have a number line, a number line like this, going this way, and on the number line, all these numbers have zero separating the negative and positive. So all these numbers 1, 2, going all the way to positive infinity, -1, -2, going all the way to negative. All these, between these there are some rational and irrational numbers. All these are what we call real numbers. Okay, so the last number system that has been discovered as at now, that you are supposed to know, is what we call the complex numbers. But now this complex number is what we call, it brings what we call the imaginary part of numbers. Okay, so that this system of numbers is really interested, and the complex number contains all the real numbers and the imaginary numbers as well. So the imaginary numbers are being represented by I, as I've said here, and is the same as square root of -1. Okay, so if I have maybe square root of -2, this is the same as, from said square root of 2 multiplied by square root of -1. Okay, when you multiply these two, you get back square root of -2, and this is the same as square root of 2 then I in complex numbers. Okay, so if I have, let's say, square root of -4, this is the same as square root of 4 times square root of -1, and square root of 4 is 2, then square root of -1, and we have square root of -1 to be I. So 2I in terms of complex numbers, when you have square root of -4 in terms of complex numbers, is the same as 2I. Okay, so I hope you enjoyed this lesson. So this is a whole overview about our number system. In our next discussion, I'll take you through some of the relationship between some numbers. Okay, how to find out if there exists a different rational number between two rational numbers. Okay, so probably maybe if I have 3 and maybe 7, how many rational numbers can you find? If I ask you to find, let's say, 3 rational numbers between these, how will you find that? So just stay tuned and watch out for the next video. Thank you very much, and don't forget to subscribe to my channel if you have not. If you are subscribed, to kindly like my video, comment, and share it to other people to enjoy as well. Thank you.